Okay, so now in last video we learn about the concentration terms of W per W, W per V and V per V. Now let's go to the parts per million. It is also very important quantity. It is the, what is the definition? It is the parts of the solute by mass per million parts of the solution. It is the parts of the solution by mass per million parts of solution by mass. That you know what is the 1 million? 1 million, that means 10 raised to 6. So we can make a common formula for the ppm, that is weight of B upon total weight solute plus solvent into 10 raised to 6, 10 power 6. Now let's note down some important formula that we have discussed in 11th also. Parts per million by mass to volume. That means amount of solute in milligram upon amount of solution in liter. This is the parts per million by mass to volume. Now parts per million by weight to volume, or the amount of solute in gram upon amount of the solution of ml into 10 power 6. Now 10 power 6 we can merge here, that gives amount of the solute in microgram upon volume of the solution in ml. Yes. So now see, I will upload the worksheet for this all the concentration terms. Okay, and that worksheet contains some of the very good MCQs that is already asked in GE and NEET and the past GE and past NEET exams. So that I will upload. Okay, and then you solve it, and if there is doubt then we can discuss it. Now let's come to the new topic, that is the solubility. Now we have many types of solubility: solid in solid, solid in liquid, liquid in solid, according to the table that we have discussed in the first video. But here in this chapter mainly we want to discuss about solid in liquid and gas in liquid. Mainly in this chapter we will discuss gas and liquid, but let's jump to the first part, solubility of solid in liquid. Solubility of solid in liquid. Now when we dissolve any solute, here solid is solute, when solid is solute and the solvent. So when we dissolve solute and the solute in the solvent, we will get the solution. Now here we have two possibilities. One possibility is that it can be a exothermic reaction and it can be a endothermic reaction, or it can be not a exothermic or not a endothermic. But what happens when it is exothermic and endothermic? So let's discuss in each case. Okay, so now let's take a first case, that is endothermic solution. Now suppose solute plus solvent, and we will supply the heat and that will make a solution. So you can see it is an endothermic solution. Okay, now the examples are NaNO3, KNO3, NaCl and KCl, etc. That will give endothermic solution. But now what we want to discuss here? Now we want to discuss here Le-Chatelier principle. Now you know what is the Le-Chatelier principle? Yes, in 11th class, in 7th chapter, equilibrium, we have discussed what is Le-Chatelier principle. The principle was that if you make any changes to the equation will, that means equilibrium will try to nullify that effect. If you increase the temperature, reaction will try to decrease it. If you increase the pressure, reaction will try to decrease the pressure. So here we want to discuss the temperature. Now here see, here we are supplying the heat. So what happens in this solution, this type of solution, if we increase the temperature, what happens here? Let's discuss. If we increase the temperature, what happens? Just think about it. What do you want? What is my question? If we increase the temperature, what about the solubility? Solubility will increase or decrease. And remember that we are discussing solid in liquid. We are discussing solid in liquid. That means solid is a solid. Now if we increase the temperature according to Le Chatelier principle, see here, if we increase the temperature here, reaction will try to decrease it, and if it will try to decrease, the reaction will be in forward direction, and when it goes in forward direction it will make a solution. That means solubility increases. So let's write down here, solubility increases. Now similarly, if we decrease the temperature, yes, now it's very easy. If we decrease the temperature, what happens? If we decrease the temperature this side, reaction will try to increase it, and when reaction will try to increase it, it will go to the backward direction, and when it goes backward direction, we will get the solute and solvent separated. That means sometimes we are getting precipitation also. That means when we decrease the temperature, solubility decreases. Now let's take another part, that is exothermic reaction. So solute plus solvent gives solution plus heat. Examples, we can say Na2CO3 and so many more examples. Now what is exothermic? It will release the heat. So again, let's discuss what happens if we increase the temperature. What happens to the solubility? Now it is an exothermic reaction. So according to Le Chatelier principle, when we increase the temperature of the system will increase, but according to Le Chatelier principle, equilibrium will try to decrease the temperature. When it will try to decrease the temperature, it will go to the backward direction. So now it will go to the backward direction. That means we will get the solute and solvent separated. So we can say solubility decreases. Now if we decrease the temperature, reaction will try to increase the temperature, and if it will increase the temperature, reaction will go in forward direction, and if it goes forward direction, we are getting solution. That means solubility increases. That means solute, more and more amount of the solute will dissolve to the solvent and it will make a solution. So there are two parts, that is endothermic solution and exothermic solutions.